Hello, everyone, and welcome. Today, we are very honored to host Professor Marcos Martinón-Torres. Professor Martinon-Torres is an internationally recognized expert in archaeological science, specializing in ancient technologies, materials, and cross-cultural interactions. His work spans multiple continents and integrates laboratory science with archaeological theory, and we are very grateful to have him with us today. Professor Martinon-Torres, would you please explain a bit about your work and how you choose archaeological science as your discipline?
Well, first of all, thank you for having me. I'm very excited to talk to you guys. And turning to your question, I am first and foremost an archaeologist. So I'm interested in uh, past societies and particularly how they engage with materials and engineering and technologies in different contexts in the past. And I have found, of course, that using scientific methods today can help us provide more robust data, more rigorous information about how people in the past went about solving technological problems, making things, exchanging things, etc. Within that, as you know, I have done a lot of work with metals and metallurgy in particular, because I think metals are a very good vantage point, a very good starting point to understand past societies. If you think of for a moment of a world without metals, everything seems earthy in color. I'm tempted to say dull, but I'm probably exaggerating. But from the moment you have metals, you introduce in the world new colors that didn't exist, new textures, new sheens, the ability to melt and recycle and cast into any shape. So you are bringing something with a completely new materiality, with completely new material properties, which are universal, but then those are made cultural in different ways. So you have metals permeating everything from the cauldron where you cook your food, to the coin you used to pay for that food, to the ring you offer to your loved one, to the dagger you used to kill them. So metals are in every single social interaction. They are traded around the world, but how we value them, how we make them, how we use them is very culture specific. And so by studying how people obtained and used and exchanged metals, we can say something, I hope, about how they were in the world. So that's what I try to do.
Thank you. That's really mind-blowing for us. And when researching your work, we came across archaeometallurgy, and we
Mhm.
also noticed that you compare metallurgical traditions across different regions and periods. How can features such as alloy recipes, technological sequences, or resource choices help archaeologists reconstruct socioeconomic systems and trade networks? And a follow-up question to this question is, what types of technological convergence or divergence prompt you to explore broader questions about cultural evolution and cross-cultural interaction?
Right. Well, that's a complex but a very, very good question. I can see you've been doing a lot of background research. So let's start with the more specific, which is perhaps what the scientific analysis can help us with. So we can analyze, I don't know, let's say a bronze axe, for example, in different contexts. And we can look at the axe itself and its shape and the chemical composition, or maybe some slag, the metallurgical residue associated to its production. And so we can look at the chemical composition and we can see which alloy they use. So how much copper, how much tin, how much lead perhaps they put into the alloy. We can look at the microstructure and then find out if the blade of that axe has been hammered after casting to make it particularly sharp or hard, or whether it was simply left as cast. We can look at the slag associated to it, and we can maybe in this metallurgical byproduct find tiny microscopic residues of the ore, of the minerals they employed to smelt the metal, and therefore we can say something about where they were obtaining their minerals from. So something about their interaction with their environment. We can also see the temperature to which that slag was heated. So what was the temperature, the amount of oxygen or carbon monoxide in the furnace. So all of these engineering parameters are telling us how precisely these people turned their minerals into metals. So we are piece by piece reconstructing how, in a particular context, people went about uh, obtaining minerals, therefore interacting with their environment, maybe local minerals, maybe trading with faraway merchants elsewhere. Then how they turned these into objects, how those objects were finished. And so we can then compare how people in different places go about solving similar problems, and from that make inferences about how they learn. So if you and I make things in a very similar way, there is a high probability that we have learned from the same tradition, from the same person or the same group, and therefore indirectly this is telling us that there is something, that there is some connection, some direct engaging between you and me. If this is a very complex technique, not one that you can imitate or figure out just by looking at the objects, then we are saying something about a meaningful interaction between two individuals or two groups of people that must have spent time learning together. If, on the contrary, we're making objects that are very similar, but that are made in very different ways, then maybe we're just imitating same shapes, but we are learning or figuring things out completely independently. So that's a different kind of form of social interaction. If you're making an object that has the optimum composition and blade to be super hard and a perfectly sharp blade, and then we even see traces of use on that blade, we know they are creating functional tools. But it may be, as we find in other cases, that that axe actually has been made to look of a particular color. And it was never sharpened, it was never used for felling trees, and therefore it's more of a ritual object. So that's where the scientific analysis and the cross-cultural comparison can, I think, allow us to go beyond just a very superficial comparison of these two artifacts look the same and say something more meaningful about the people behind those objects, what they were aiming at, how they interacted with the world and with one another.
Thank you. That gives us a great sense of how metals features hold cultural and social information, and it's fascinating to learn how materials can become evidence for broader interactions rather than just artifacts.
Mhm.
And to build on the idea of materials reflecting people and practices, in your publications, materials are treated not only as economic resources, but also as expressions of cognition and skill. When examining artifacts and production debris, which attributes such as tool marks, microstructural transformations, or thermal histories allow you to infer decision making, technological constraints, apprenticeship systems, or levels of craft specialization among past metalworkers?
Well, I think I was already giving you some examples of how, looking at microstructures and compositions, we can make inferences about what people did. Ultimately, I suppose when we do archaeological science, or archaeometallurgy in particular, what we have is, on the one hand, the laws of physics and chemistry are universal. And so we know what those fundamental constraints are, whether you are, in one place or in another. Those constraints are the same in the past and in the present, and in Africa and in Europe generally. And then on top of that, we have our culture, which is what, within those constraints, there's always room for choice. There's always, as they say, 100 ways to skin a cat. And so the laws of nature, the chemistry and the physics gives us the basic baseline. And then we can see within those constraints how people operate differently, which is what I find fascinating, because ultimately what we are seeing is human diversity in the past.
Thank you. That really highlights how materials actually hold intentional human history. And it suggests that the artifacts that we leave behind isn't just objects. Güneş, would you please follow? Would you
I'll
please?
be continuing with the other question. This raises a larger question of scale because once we have detailed lab data, we still need to interpret it in historical and social terms. So our next question looks at the interpretive challenge. Compositional and microstructural analysis can contribute to models of trade, political organization, and resource management, but interpretive steps are often complex and multiscalar. How do you bridge laboratory data, for example, isotopic signatures, compositions, or phase distributions, with historical interpretations about socioeconomic systems or political power, and what methodological limitations or uncertainties do archaeometallurgists need to navigate when making these connections?
Well, that's another interesting, big, and challenging questions. So you're absolutely right that on the one hand we have the hard data and the characterization, and on the other hand the interpretive challenges, as I think you were calling them. And I think we have to have both in every study. The way I work certainly is always led by the questions about the past, the questions about people. So I use a lot of machines, a lot of laboratory analysis, but ultimately I'm more interested in people and people's behavior than the intricacies of the materials, as much as I like looking at the materials as well. But they are a means to an end. And so that theoretical framework, if you like, the more anthropological framework is always necessary. And so to give you some examples in practice of how we can make inferences, as you were saying, about craft organizations or political systems, uh, in a nutshell, if we analyze a lot of artifacts, let's say a lot of gold rings, for example, and they all under the microscope look exactly the same. They have been made with the same tools because often we can see tool marks. They have very similar compositions. The various components have been soldered using the same technique. That to us is suggestive of perhaps all of them having been made in the same workshop in a very standardized way. So everyone learning in the same way or under the same supervision with the same tools. And that's telling us something about the organization of the crafts. It may well be that this workshop is producing at the service of a chief or somebody who has the power to organize this workshop, who perhaps controls access to gold, access to knowledge, etc. At the other end of the spectrum, we can have, for example, a lot more diversity, rings that on the surface look the same, but where we find different chemical compositions, perhaps different geochemical or isotopic signatures that suggest that the gold is coming from a lot of different places, or we have that the rings actually, some are made with slightly different techniques or different skill levels or different taste. And so that would suggest that many more people are involved in the making of these rings. Perhaps access to knowledge and access to gold is more widespread, and there is a more communal management of these resources. So this is just one example of how the archaeometallurgical data, when aggregated and scaled up, can help us, in combination with other information, say something that's potentially meaningful about how the society is organized. I don't know if that answers your question. I can't remember if you're asking me something else.
No, thank you for breaking that down. It shows how archaeological science has to navigate both analytical complexity and the historical uncertainty when connecting materials to society. And um, and another approach you've emphasized in your work is reverse engineering, which seems to provide a different angle for understanding ancient technologies. So we wanted to ask you about that specifically. A recurring theme in your work is the use of reverse engineering. Could you explain how reverse engineering works in archaeological contexts and what it can reveal about the skills, knowledge, and decision making of people in those time periods?
Sure, you're right that reverse engineering is very recurrent in my work, and it's not something that I have invented because, of course, it's something that still applies to present day engineering contexts. So, in terms of design, most of us are familiar with a sequence in engineering that goes from we have a problem The next step is we're going to design a robot, a machine, a process that solves that problem. The next step would be manufacturing that machine that will address the problem, and eventually we have that machine. So we go from a problem to an idea design to manufacturing to having that object. The way in which I work and a lot of my colleagues do is what we find is the end product, that finished object that we find in the archaeological excavation. And through scientific investigation, we go back to trying to understand how the object was manufactured, as we have just been discussed, and then back to it was manufactured in this way because it was designed in that particular way. And then we try to take the leap to what was the problem, what was the idea, what was the inspiration or the problem or the social need that drove to the manufacturer. So basically, reverse engineering is working back from the finished objects to the idea, which is something that people still do today in industrial espionage, for example, when you're trying to create a cheaper copy of your competitors. That's a context where reverse engineering continues to play a very important role.
Thank you. It's very interesting to think of reverse engineering as a way of reconnecting ancient knowledge systems, not just ancient object, like you said, the social needs for that. And Zahra will be following with the rest.
Thank you, Ganesh. And I believe what you have talked about connects to the range of scientific tools available in modern labs today. And as a robotics team, we also research technologies in archaeology. Your research combines a wide range of analytical techniques, including scanning electron microscopy, energy dispersive X-ray spectroscopy, and many others. How do you decide which methods are most appropriate for a study? Have there been cases where scientific results contradicted with existing historical assumptions?
Sure. In terms of how we decide which techniques to use when, on the one hand, it is the question, what do we want to find out? If we're interested, for example, in determining where this metal or this material comes from, we need techniques that give us trace elements or isotopic data that we can then compare to geological reference data. So that will be a particular set of techniques. If I'm interested in how the object was made, then I will probably need microscopy among other techniques. If I'm interested in if there's a residue within this ceramic, I will need different techniques, and those will change depending on whether the residue is organic or inorganic, for example. In addition to that, which is the ideal, we have to be realistic, and sometimes there are questions of availability. Do we have that machine available to us in our laboratory? Or do we need a portable machine because the object cannot be brought to our laboratories here? What is the budget? And also importantly, can we remove samples from the archaeological art? Some of these techniques are invasive, so we need to extract a minute sample from the artifacts, whereas others are completely non-invasive. So we only analyze the surface of the artifacts without touching them. And that depends on how unique they are, whether they are broken already, because if they're not broken, we will not break them. And so there's a set of challenges, I suppose, or constraints that we work within. So that was the first part of the question. The other one was about challenging historical assumptions, right? So on that note, we always, where there are historical sources, we try to combine, of course, the archaeological information with the historical information. And yes, often we find that they don't agree entirely, and therefore it's interesting to try to understand the limitations of both types of sources. So let me try to think of an example. So if you read the amount of gold that was brought from the Americas into Europe in the period of the colonization of Americas, you will have information from official government sources of how much gold or silver they taxed. That is one historical reality. The real reality that archaeology can reveal is that the amount of gold and silver brought was much higher because, of course, people would not declare every piece of gold that they would put on their ships. Or historical documents will tell us about how much metal is extracted in a particular mine, but it will not tell us about all the metal that's constantly being recycled day to day in small workshops across a particular landscape. So in that sense, the archaeology may give us more concrete evidence of the day to day, of the real life of people, as opposed to what may be written in a book. What we shouldn't forget is that when something is written down in what we then use as historical sources, it is written for a reason and for a particular purpose. And that in itself often means there is a bias. Nothing is ever perfectly accurate. Also, the archaeological record is, of course, limited, but by combining them, we compensate for the challenges and limitations of each data source. We get richer narratives and we get contradictions. Well, it's more interesting. But if I may, I think you're talking about historical assumptions more generally, and in general, what I would say is that the biggest historical assumption that keeps being dispelled in our study of past technologies is that past technologies were always aiming for cost efficiency, practical optimization, economic optimization, and that everything evolves from very rudimentary, basic, primitive, which is a word we shouldn't use in technologies, but that's the historical assumption, to the more sophisticated, efficient, complex, intelligent world of today. And we tend to think of the history of technologies that way. And what archaeology reveals is that nothing farther from reality, because technologies are extremely complex from the very beginning, first of all, extremely intelligent. There's no such thing as that unilinear evolution in many cases. There is a million different ways in which technologies evolve in various locations, not always in ways that which would define as cost efficient or economic, because for efficiency and economics have not been the prime preoccupations of people. And people were a lot more playful or developed technologies because they were interesting or beautiful or because they were ritually necessary, not because they were obsessed about saving time and saving money. And so that is certainly an assumption which is very presentist. We assume people in the past function in the same way we function today. And that's something that archaeology constantly reminds us that no, that's not the case.
Thank you. And that shows how analytical and constraints shape the kinds of insights we can get from our studies, and how scientific and archaeological results can refine or challenge established narratives. And this brings us to the issue of scale again, because I believe that archaeological science has to move between microanalytical data and broader cultural context. And archaeological science often operates across different scales of analysis, like you mentioned, microstructural examination to regional cultural interpretation. And you work in both the laboratory and the broader theoretical space. How do you determine when a research problem requires microanalytical techniques such as metallography or microbe analysis, and when it requires a broader contextual approach grounded in historical, ethnographic, or landscape data?
Well, that's another good question. And some of these issues we were discussing earlier, weren't we? I think it's true that sometimes we have very concrete questions because we find an artifact or we find metallurgical slag, and the initial question is, well, what is this? How was this made? And so in those cases, we can be very method driven. Okay, I want to understand what's this material. I'm going to put it under a microscope. I want to do a chemical analysis to get a sense of what it is. And that is the micro scale. But as we begin to aggregate many of those micro scales, of course, we begin to draw comparisons. We begin to get a sense of a bigger picture. And that is when things get more, for me, interesting, because we can begin to talk about people, we can compare between different societies, etc. So as things build up from the micro to the macro, we move from individual objects to societies, to landscapes, to broader scales of analysis. And all of those studies are appropriate. We need the micro so we can talk about the macro, but it's useful to have the macro in the background when you do the micro so that you know why you're doing what you're doing.
Okay, thank you for that. And it really illustrates how flexible the field can be and needs to be, shifting from lab work to contextual interpretation. And
Okay, so I'll be moving on with our next question. Since many of these approaches that we talked about depend on collaboration across disciplines, our next question looks at how those collaborations shape both methods and theory. Much of your work involves collaboration with chemists, material scientists, and computational analysts. Students in interdisciplinary environments often wonder how new methods reshape research questions. How have collaborations with specialists from other scientific fields influenced analytical techniques you employ, and in what ways have they expanded or shifted the theoretical questions you pursue within archaeological science?
So how can we answer this? I think the key to fruitful collaborations is mutual respect and acknowledging that in a group of people with different backgrounds from different disciplines, hopefully everyone has something to bring to the table, but also and importantly, everyone has something to learn. And so no discipline in a way is superior to the other. Now, I have learned a lot from interacting and working with scientists, from engineers to physicists or chemists, or increasingly specialists in computational approaches, because they bring the specific technical knowledge. I have learned from them a lot about rigor, about reproducibility, about the fact that if you do science in archaeology, the science has to be as good as science in any other domain. But then those of us who come from the historical or archaeological or humanities backgrounds hopefully can contribute with our, on the one hand, anthropological understanding, framing the questions, framing the interpretations, but also our specialist knowledge of how you do an excavation, interrogate an object, and work with the very challenging fragmentary information that we obtain in archaeological contexts. So without any doubt, working with scientists has often changed the way I approach things. It has improved my questions. It has maybe enriched me as a professional and as a person. But I would like to think that if you were asking colleagues, hopefully they will also say they something and they've enjoyed at least the interactions with the archaeologists. And as I said, ultimately, we need to learn enough about each other's world so we can interact, so we can have conversations. But then we also have to not be embarrassed about the things we don't know, because we also have to be confident about the things we do know, which are different. And so we find those areas of overlap, those areas where we don't overlap, and it just creates very fruitful, very creative environments, provided that we respect one another.
Thank you. That's also very helpful for students to hear, especially about how interdisciplinary environments can reshape the questions and approaches. And like you said, how when the two worlds interact, more fruitful things happen. And finally, we wanted to ask you about the future, because computational tools and new imaging techniques are rapidly changing many scientific fields, like high resolution imaging, big data approaches, and computational modeling are transforming many areas of science, including archaeology. Which emerging analytical and computational tools, such as machine learning or for pattern recognition, advanced 3D imaging of metallurgical remains, and geochemical provenancing algorithms, do you believe will most significantly reshape archaeological science in the next decade, and why?
Well, this again shows that you are very up with what's happening in archaeological science. So well done you. And absolutely, yes, without any doubt, machine learning and more generally AI approaches are beginning to have a massive impact in archaeology, as they do, of course, beyond archaeology. Um, Pattern recognition, as you were saying, is critical. For example, we have more and more data on analysis of different mineral sources around the world. We want to compare the geochemical fingerprint of our artifacts to the thousands, hundreds of thousands now of individual analysis of rocks and minerals around the world. It is very useful now to have advanced computational approaches to try to separate or make sense out of those millions of data points and do the most accurate comparisons to our archaeological data. Or we do have increasing amounts of 3D images of artifacts, sometimes not just of the surface, but also of the inner structure when we do micro CT scanning, which we do a lot on archaeological artifacts. So we have very complex data sets that include different shapes, but also different microstructures. And as we add more and more to these data sets, we do need computers to help us make sense of them. And I'm now about to begin a new project in collaboration with the Department of Mathematics here in Cambridge, as well as with the Fitzwilliam Museum, also in Cambridge, to use or to begin to test the use of AI in integrating these messy multimodal data sets, which are partly images, partly spectral data, partly numerical, partly qualitative, and how we integrate all of those. So yes, it is changing the way we go about things, but I would emphasize that we, as we were saying earlier, we still need the science, in this case computation, but we need the humanities. All of these AI and computational approaches that some people are worried about, I'm not worried. I think they are indeed very useful, but they are useful in showing us the how, if you like. They help us with the how of solving a problem. But you still need the human and the humanities to ask, first of all, what? What do we want to do? And then we can get the help of the science to do with the how. How do we do that? And then the human comes back to do the so what? Why is this important? Why is this relevant, if at all? So machines are great, but humans are okay too. So we need to keep humans in the equation.
Thank you. It's really exciting to hear how new tools might transform archaeological science in the coming years. And like you said, how both of these worlds push each other to be better. Um,
Thank you.
if we can take some questions from our audience, if they'd like to. You could raise your hands or just, I think, jump right in. I guess we don't have any. Thank you, Professor Martinon-Torres. Thank you so much for sharing your time and expertise with us today. We really appreciate the insights into both scientific and the cultural dimensions of archaeological research. And thank you everyone who joined us. We had a really great time.
Thank you for having me. It's been really interesting talking to you. And I have to say, I'm amazed by how well prepared you were for this. Much better than many journalists. You've made very pertinent questions, and I've enjoyed my time with you. Good luck with your work. And it's great to see more and more people appreciating that we can work at the interface between the sciences and the humanities, and that even if you are a STEM specialist, we want you in archaeology, and you can have the best of both worlds.
Thank you so much.
Thank you.
You had really great insights, and I believe that me and Gunesh were really excited to learn more about archaeometallurgy because we researched a lot, and we actually were really excited when you answered our email. And if your destination ever comes to Turkey, please visit us. We would love to have you in our school and have you visit it, and we could maybe explain our historical side of our school and the buildings there.
Brilliant. Thank you.